Good day and hello. My name is Patrick Filkins, Senior Research Analyst at IDC covering network infrastructure. Today, I'm joining you to share IDC's views on passive optical LAN, also called POL or POLAN. POLAN is a fiber optic-based network solution designed to help enterprises address today's network transformation challenges, particularly at the campus domain. To start, I will share IDC's view on network transformation as a subsegment of digital transformation and discuss how enterprises, particularly enterprise campuses, can leverage fiber optic networks to support digital transformation trends. These trends include cloud, Wi-Fi 6, and IoT, to name a few. After spending a few minutes discussing DX and how it impacts enterprises, we will spend more time discussing POLAN directly, as it is important to understand how POLAN differs from traditional campus networking solutions, and how POLAN can help address today's enterprise challenges. As such, after this presentation, you will have a good understanding of the issues enterprises face today, what they will face over the next several years. You will also understand how choices related to enterprise campus networks can impact their ability to execute strategically. With that said, let's get started. As noted, we will start by defining what we mean by digital transformation. IDC has taken a broad approach to this exercise, using a stepwise method to examine how enterprises are and will be impacted. At IDC, we commonly encompass our thoughts on the current digital transformation landscape through what we call the third platform. The third platform covers technology trends starting in the early to mid-2000s through today and what we expect to see in the future. It's based on four key pillars. Those include cloud, social, big data, and mobility. These four trends all embody what the third platform is today. Further, we've seen emergence of what IDC calls innovation accelerators. These accelerators include AR/VR, 3D printing, IoT, artificial intelligence, blockchain, robotics, and next-generation security. Also to note, IDC sees most industries moving past simple experimentation with these technologies into what we call multiplied innovation. This means enterprises are increasingly using these tools to enhance operations, differentiate competitively, and position for the future. While these are all separate in some regards, they all share one key feature: the need for improved connectivity. Whether application or use case, these accelerators will need a network to support functionality at scale. So let's provide some more context about where we are in the third platform. As you can see, we are in the era of multiplied innovation. The recombinant use of cloud, social, mobile, and big data, which includes things like Wi-Fi 6, Edge IoT, and Edge Cloud, mean enterprises need to ensure these tools run smoothly. Once again, the network becomes the key connector to all these promising endeavors. Now, I'd like to focus solely on the network portion of digital transformation. As noted, digital transformation requires network transformation. As such, network is a foundational layer for enabling secure, scalable, and efficient use of cloud, edge, and IoT applications. Focusing solely on enterprise networking, IDC observes organizations ranging from hotels, utilities, educational campuses, hospitals, and others accelerating their network transformation. This generally means focus on network transformation as it relates to digital transformation, the use of things like Wi-Fi 6 and other access modalities like LTE and 5G, machine learning, AI, network analytics, IoT edge applications and solutions, and cloud networking. As a whole, enterprise networking is becoming more complex, and enterprise networks need to evolve to address many use cases and applications at once. This becomes the main challenge network administrators will address. Said differently, enterprise network solutions need to evolve and also prepare organizations for these long-term changes. Diving deeper, I'd like to quickly discuss 5 key trends impacting enterprise networks today, and as we'll discuss in the following slides, campus networks. First, enterprise networks need to embody centralized control and management. Simply overlaying network and network control systems is not an option. Less networks for single use cases, more network control. Second, enterprise networks need to support more video traffic. In today's COVID-19 environment, more employees are using video applications, which can be hosted on-premise or from the cloud. Mobile employee devices are also increasingly used for video tools. As video continues to proliferate, enterprise networks risk becoming bottlenecks. Third, cloud-managed solutions continue to rise. Organizations increasingly rely on cloud providers to deliver a host of applications and services. This enables organizations to outsource IT. It can create problems if the on-premise network is not upgraded as well. Fourth, Wi-Fi 6 is coming. IDC expects significant ramp in 802.11ax deployments. With new access points expected to scale over the next several years, enterprise campuses will be flooded with new data not only from the cloud, but from end users and end devices. It should be clear now that existing campus networks will be under intense pressure to keep pace to support top-down pressure from the cloud, but also pressure from the end device. And finally, fifth, private LTE and 5G solutions. IDC has observed a number of private cellular rollouts globally. This will only increase. If organizations desire to close campus networks and create private infrastructure, they will need to consider how their on-premise networks adapt to the impact of cellular use cases, such as more mobile devices, cellular IoT, and 5G. As we've discussed the technology problems in depth, it's worth spending a minute or two to touch on the business impact. I will now share with you two sets of data, one from an IDC IT strategy survey and another from an IDC survey which discussed enterprise edge networking. The first data set asks, what are the top 3 drivers for placing applications in an edge location? As you can see from the first slide, security is of utmost performance, a common occurrence in almost all enterprise surveys. While this is important to note, look further. Enterprises rate lowering costs and improving latency in the top 2. Also included are drivers such as modernizing infrastructure and IoT. These all relate to the network. I'd also like to read verbatim some of IDC's findings. In 2023, 68% of all data will reside in core edge locations. Again, a potential impact to data creation at the network layer. Now let's look at the second data set. This data set asks, do you agree with the following statements? Statement 1, my organization is supporting far more devices, servers, and application in a remote branch location than ever before. As you can see, 81% of respondents agree that more devices will be placed at the edge, which could be a branch or campus location. Many of these devices will be enabled by Wi-Fi 6 or even 5G. The next one, my organization's network need to have the flexibility to address the complex physics needs in local, remote, or branch locations. 78% agree. And finally, in my organization, intelligence is increasingly pushed to the edge. 68% agree. As a whole, enterprises need to recognize how these technical trends impact business potential, and conversely, how business drivers can have an impact on the network. So far, we've covered digital transformation and IDC's view on third platform, how enterprises are viewing their network as a tool to address these changes, specific technologies such as cloud, Wi-Fi 6, and IoT. Now, I'd like to shift the discussion to a specific network architecture which is designed to address these trends. That solution, as noted, is POLAN. In discussing POLAN, we will cover what POLAN is, the expected benefits, and how it can help solve today and tomorrow's use cases. As noted, POLAN is a fiber optic based solution for enterprise campus networks. It borrows many of the characteristics from service provider gigabit passive optical networks, or GPON, but is form-fitted for enterprise campuses. This includes the ability to house network infrastructure within indoor closets, walls, and ceilings to accommodate the unique environment enterprise verticals require, and enable organizations to extend fiber as close as possible to the endpoint. POL consists of an optical line terminal, PON splitter, and a series of optical network units, ONUs, all connected by single-mode fiber. This architecture is proving to be a stronger solution across a number of metrics, particularly in greenfield environments, such as a new commercial building, hotel, or university campus. As we discuss POLAN in comparison to other market solutions, such as Ethernet access, it's useful to compare them side by side to understand some of the benefits POLAN can provide, and why you should consider it when deploying a campus network. Let's compare POLAN to traditional Ethernet access in a graphic. Using this graphic, we can see that POLAN aligns closely to existing architectures, including placing OLTs in the data center campus core domain, PON splitters in a campus network building itself, and then ONUs in the individual room or wiring closet. The ONU can then either enable fiber to the endpoint or support Power over Ethernet, PoE, which can connect to both wired and wireless access points. Traditional Ethernet access also places switches at the data center campus core and individual room wiring closet, but often requires aggregation switches in the building as well. This can result in more spend on traditional network infrastructure in comparison to POLAN. In the case of POLAN, the use of single-mode fiber enables enterprises to deploy network infrastructure further apart, as opposed to the traditional use of Cat5 or Cat6 copper cabling. As such, the impact can be substantial across a POL deployment, as the front-end costs of deploying network infrastructure to supporting and maintaining that infrastructure are reduced. Further, having less electronics means less energy usage, reducing day-to-day costs. Overall, the key takeaway is POL can result in a lower total cost of operation in comparison to traditional Ethernet access. Let's take a look now at some other benefits POL can provide. First, fiber optics can enhance LAN bandwidth both today and future-proof for tomorrow. In the case of Wi-Fi 6, enterprises are likely to need at least a 10 gigabit backhaul solution. POL can surpass that easily, shielding enterprises from the potential network bottlenecks Wi-Fi 6 may produce. Second, fiber optics technology can help to improve application performance, regardless of where the application is deployed, which could be in the cloud, at the core, or an edge location. Third, POLAN supports the concept of a single network for multiple use cases, with a centralized management on top. Centralized management is required for most enterprises as a means to reduce network complexity and improve overall operations. Fourth, as noted, POLAN can reduce energy expenditure. In many regions, new building codes are pressuring building owners to adapt to stricter, greener energy requirements. In the case of greenfield builds, IDC supports the notion that more building owners are becoming interested in POLAN as a means to meet stricter codes by reducing energy output from less electronics and less copper cabling. Finally, POLAN can help reduce overall CapEx and OpEx. As noted, less electronics reduces upfront costs, while also reducing day-to-day spend on power and maintenance. Now, let's examine how POL is being deployed across some enterprise verticals. In each instance, POL aligns nicely to the unique demands from each use case. In today's call, we'd like to highlight how POL is positively impacting specific verticals. They are hotels, universities, hospitals, and government buildings. In the case of hotels, POL networks are being deployed to handle all potential use cases on a single network. This includes room services like wireless broadband, TV, and telephony, as well as smart building automation such as elevators, kiosks, smart signage, and door locks. Further, POLAN is being deployed to handle the traditional back-office IT required on-premise in a hotel. Once again, POL addresses all these use cases at once. In the case of university campuses, POL is viewed as a safer solution and enables the connecting of office, dormitory, athletic, and food venues, all with their own unique needs across network performance. Government centers also are looking more closely at POL as a means to connect sprawling campuses, which may require different things from the network depending on the use case. Finally, hospitals in select regions are beginning to look more favorably on POL. For example, one use case is CT imaging, whereby a POL network provides near real-time sharing of images, helping improve patient care. Said differently, as all verticals undertake their own transformation initiatives, which includes expanding across a number of use cases, the network needs to be ready for any potential scenario. In closing, IDC would like to provide some guidance to all enterprise customers and those considering how they will upgrade their campus networks to meet these future needs. First, define your network transformation goals in the context of broader digital transformation. Your use cases and applications can help to define your network needs. While POL is designed to address most use cases and scenarios, it is important to not lose sight of what your network is trying to support. Second, network transformation is becoming very broad, encompassing many technologies including machine learning, artificial intelligence, network analytics, cloud, Wi-Fi 6, IoT edge, and big data. The network needs to become more simple than a pipe, but a future-proof tool, capable of delivering on performance, but also intelligence. Third, in comparison to traditional architecture, POL has the potential to reduce both upfront and day-to-day costs. And finally, in the case of greenfield builds, POLAN should be considered, as it can help building owners align to increasingly strict energy codes. That concludes today's presentation. Thank you.